Hi, this is Jashwant Grandi, and today I'm here to discuss your physics part test 12 paper. So let us proceed. A capacitance 2 microfarad is connected to a cell of EMF 20 volt. The plates of the capacitor are drawn apart slowly to double the distance between them. The work done by the external agent on the plates of the capacitor. Let us make a simple table here depicting initial and final values. So we'll write initial and final values of capacitance and charge. Charge in the sense, charge on the capacitor. So what is the initial value of the capacitance given, which is 2 microfarad? And what is the initial value of charge on the capacitor? So obviously this is positively charged, this is negatively charged. The charge is Q is equal to CV. You already know this. C is capacitance of the capacitor and V is voltage applied across the capacitor. That would give me initial charge to be 2 into 20, which is 40 microcoulomb. This is the initial. And coming to the final, what is the final capacitance? You know that capacitance is epsilon naught A by D. Epsilon naught is not changing because the medium between the plates is not changing, and A, area of the plate, is also not changing. Whereas distance between the plates is becoming double. D becomes 2D. This implies C becomes C by 2. Therefore, if the initial value of the capacitance is 2 microfarad, then the final value becomes 1 microfarad. And what about the charge on the plates? Q is equal to CV. V is same, but C is becoming half. Therefore, Q also becomes half, which is 20 microcoulomb. Now, in order to solve these kind of questions, just remember this equation. Change in potential energy stored in the capacitor or energy given to the capacitor is work done by the external force plus work done by the battery minus heat released by the system. Now here we are assuming that a battery is ideal without any internal resistance, therefore heat released is 0. Now let us proceed solving this. So change in potential energy of the capacitor, which is final potential energy minus initial potential energy. Final is half C by 2 V square minus initial is half CV square, where C is 2 and C by 2 is 1. That is equal to work done by external plus work done by the battery. Now work done by the battery is very simple. That is change in the charge delta Q into EMF of the battery. What is change in the charge? Initial charge on the plate of the capacitor is 40, final is 20. Correct? So final minus initial, that is change in the charge, which is 20 minus 40, final minus initial, into EMF of the battery, which is 20. So this will give, this is minus 1 by 4 CV square, that is equal to work done by external, and this is minus 400. And this is minus 1 by 4 into C is 2 and V square is 400 again. That is equal to work done by external minus 400. This implies work done by external is equal to, this becomes 100 minus 200 plus 400. So work done by external agent is 200 microjoules. So option A is correct. Proceeding to the next question. Look at this question. A set of n identical resistances, each of resistance R ohm, when connected in series have effective resistance X. And when the resistance are connected in parallel, the effective resistance is Y. The relationship between R, X and Y. This is a simple question. So when resistances are connected in series, so X is equal to R plus R plus R and so on up to n times. This is NR. When resistances are connected in parallel, Y or I can say 1 by y is equal to 1 by r plus 1 by r plus 1 by r up to n times, which is n by r. This implies y is equal to r by n. Now just multiply these two equations. Xy is equal to nr into r by n. R by n cancel. So you would get r square is xy. I've written capital X and Y here. Actually, they are small letters. So r is equal to under root xy. So option A is correct again. Proceeding to the next question. A particle starts from rest at a distance of r from the center and along the axis of a fixed ring of radius r and mass m. Its velocity at the center of the ring. So you could call this as position 1 and this as position 2. As simple as that. So total energy at position 1 is equal to total energy at position 2, which is kinetic plus potential is equal to kinetic energy at 2 plus potential energy at 2. So what is kinetic energy at 1? It is given that particle starts from rest, so initial kinetic energy is 0. And what is the potential energy? When the particle is at this position, every other particle on this ring is at a distance of this, which is r root 2. Correct or not? You can make a right angle triangle here, r root 2. Therefore, initial potential energy is equal to minus g capital M small m divided by the distance, which is root 2r. And final potential energy, which is when the particle is here, that time every other particle of the ring is at an equal distance of r from this small particle. Therefore, final potential energy becomes minus g capital M small m divided by r directly. So putting in all these values, you would get minus g capital M small m by root 2r, that is equal to final kinetic energy, which is half mv square plus final potential energy minus g capital M small m by r. So half mv square is equal to, taking minus capital G small m by r common, you would get 1 by root 2 and minus 1, if I'm not wrong. Yeah. So small m gets cancelled and you will get v square is equal to minus g capital M small m, minus g capital M by r into 1 by root 2 into 2, which is root 2 minus 2. So v is equal to under root of gm by r. If I multiply this minus sign inside, you will get 2 minus root 2. 2 minus root 2, which is option D. Moving on to the next question. 3 solid spheres, each of mass m and radius r, are released from the position as shown here. The speed of any one sphere at the time of collision. So at the time of collision, the 3 spheres would be touching each other like this. Therefore, distance between any 2 spheres would be 2r at the time of collision. Initially, what is the distance between 2 spheres? It is d. And this is very much similar to the previous question. Same thing that you're going to do. This is initial position and this is final position. total energy at initial position is equal to total energy at final position, which is kinetic energy plus potential energy is equal to kinetic energy finally plus potential energy finally. Initially, the spheres are released, so kinetic energy is 0. And what is the potential energy initially for the system? So these two spheres are at distance d, so it is minus g small m into small m, which is m square by r. And between these two, it is again minus g m square by r. And between these two, it is again minus g m square by r. That is equal to final kinetic energy, which is half mv square into 3, because all the three spheres will be moving simultaneously, plus final potential energy. This time the distance between the spheres is 2r. I'm sorry, the initial distance between the spheres was not r, it was d. So let me replace that here. It is d, d and d. This is the initial distance between any two spheres. And final distance between any two spheres is, directly I'm writing minus 3g m square by 2r. Because finally the distance between any two spheres is 2r. This one. So solving this further, you would get 3 by 2 mv square is equal to minus 3 gm square by d plus 3 gm square by 2r. So 3 cancels out and m also cancels out. And multiplying 2, so you would get v square is equal to minus 2gm by d plus gm by r. 2r and 2 gets cancelled out. So v is equal to under root of gm by r minus 2gm by d. So which option is correct here? So this is v is equal to under root gm 1 by r minus 2 by d. I think none of the option is satisfying this. The answer is given as option D. So obviously this has to be under root gm 1 by r minus 2 by d. This should be the correct option. So there is some mistake with the option. Hope you understood. Next question. So look here, the variation of energy with orbit radius of a body in a circular planetary motion. Find the correct statement about ABC. First of all, do you remember the energy, that is total energy is equal to kinetic energy plus potential energy. Kinetic energy is always positive, whereas kinetic energy is always positive. Total energy should always be negative because we are talking about stable system here. This implies potential energy also should be negative for total to be negative. Therefore, kinetic is positive. That means A is positive. So this should be kinetic energy. And B and C should be potential and total energy. Now numerically, which one is greater? Total energy is greater or potential energy is greater? Numerically, not with sign, only magnitude wise. Magnitude wise, potential energy is greater, because it is something like this. If you take kinetic energy as 1 and potential energy as -2, then total energy would be -1. I'm just taking an example. So if you compare total energy and potential energy is larger in magnitude. This is 2, whereas total energy is 1 in magnitude. Therefore, the curve that is away, that should be potential energy, and curve that is near, that should be total energy. So which option is satisfying all the requirements here? Look at option D. A and B are kinetic and potential energies, and C is the total energy of the system. Total spelling is wrong. Okay. Proceeding to the next question. A point charge Q is within the cavity of an electrically neutral conducting shell whose outer surface has spherical shape. Okay, cavity is not spherical actually, it is some random shape. Find the potential V at a point P lying outside the shell at a distance of R from the center O of the outer sphere. Okay. So let us understand this question. There is Q inside the cavity. Now if you take a Gaussian surface which is within the metal, then obviously the electric field on this Gaussian surface will be 0. That means flux passing through this surface, whichever I have drawn, imaginary surface is 0. That means charge enclosed should be 0, because of which there is Q charge inside. So there will be minus Q charge developed on the inside of the cavity. Now cavity is not symmetric, nor the charge Q is at the center, because of which the inside charge distribution on this surface is not even, it is uneven, but we are not bothered about that. And the total metal is neutral, so even after charge induction it should be neutral. So in order to compensate that negative charge, there will be some positive charge induced on the surface of the metal, like this. Now since the outer surface is symmetrical, it is spherical in shape, the charge distribution is also uniform. With respect to point P, these charges, the Q inside and this negative induced charge inside, will not play any role. In other words, this exterior point is only influenced by this exterior charge, or this Q which is inside the cavity is unaffected by the surrounding outside the sphere. This is only called electrostatic shielding. You must have learned this. Okay, let us finish this question, then we'll discuss some interesting stuff about this electrostatic shielding. So as I told you, this point P is only under the influence of this positive charge on the surface of the sphere. The inside of the sphere, that is cavity charge and Q, does not affect point P. Therefore, for point P, this symmetric charge looks like a point charge at the center. Because this is symmetrically distributed on the sphere, this can be replaced with a point charge at the center. You can remove the entire sphere and just put a point charge at the center, which is at a distance of R from the center. Therefore, the potential here will be V is equal to K Q upon R. As simple as that. So K is what? 1 by 4 pi epsilon naught. So the answer is first option. That is 1 by 4 pi epsilon naught Q upon R. This is the correct answer. Now I was talking about electrostatic shielding earlier. I'll just propose a small experiment. You all are at your home, so you can actually do this experiment. All you need is 2 mobile phones and 1 aluminium foil. Aluminium foil is the one you use to wrap the food and all. aluminum foil. So what you do, you take one phone and cover it up completely in aluminum foil. Okay, you don't put that phone in silent mode or aeroplane mode or anything. Just keep it normal and wrap it up in aluminum foil from all the sides. Now take the other phone that you have and try to call this phone which is inside the aluminum foil. You will see that the connection will not be established. In fact, you will get out of reach or not available or something. Reason is that this aluminum foil acts as shielder. So it is shielding all the electromagnetic waves, to be specific, electric field outside the aluminum foil. So it is protecting something which is inside from the outside fields. This is only called electrostatic shielding. It's an interesting experiment. You can try. Next question. Look at this. Two identical particles of charge q each are connected by a massless spring of force constant k. They are placed over a smooth horizontal surface. They are released when the separation between them is r and the spring is unstretched. If the maximum extension of the spring is r again, then what is the value of k? See, you can see that there is no friction or any other kind of dissipative forces. Therefore, you can conserve the energy. So you can say this is position 1, and this when it stretches to this position, and this also when it stretches to this position, where the total elongation is r, you can call this position 2. Therefore, total energy at position 1 is equal to total energy at position 2, conservation of mechanical energy. So this is kinetic energy at position 1 plus potential energy. Now potential energy is in two forms: spring potential energy and electrostatic potential energy. So spring potential energy, I will call it US1, and electrostatic potential energy, I'll call it UE1. That is equal to K2 plus US2 plus UE2. Now initially they are released. In other words, you could say the masses are at rest initially. So kinetic energy is 0. And what the question says, what is the, if the maximum extension in the spring is r. See, when does the spring extend maximum? When the blocks again stop, come to rest momentarily. Therefore, the final kinetic energy is also 0. Maximum extension ante the kinetic energy, the block comes to rest momentarily. So basically you need to conserve all the potential energies. So initially spring is in an unstretched position. So initial spring potential energy is also 0. As simple as this. Then plug in all the values. What is the initial electrostatic potential energy? K q1 q2, which is q square divided by distance between the charges, which is r, right? Yeah, r. That is equal to final spring potential energy, which is half kx square, half k into x. X is basically r only because maximum extension is r. So r square plus final electrostatic potential energy, which is again k q square by new separation between the blocks. Initial separation is r and extension is also r, so new separation would be 2r. Yes. So solve this, and you may be getting confused between k's. These are not the same k. This k is 1 by 4 pi epsilon naught, and this k is spring constant, and again this is 1 by 4 pi epsilon naught. So to keep them distinguished, I'll put k dash k dash. Okay, so don't be confused. So k dash q square by r, bringing that here, 1 minus 1 by 2, that is equal to half k r square. Correct? So this will give 1 by 4 pi epsilon naught q square by r into half, that is equal to half k r square. Half cancels out and k becomes q square by 4 pi epsilon naught r cube. Okay, so which option is satisfying this? It is option B. So 32nd question, option B. Hope everyone understood. Let's go to the next question. Two bodies of mass m1 and m2 are initially at rest at distance of r apart. Then they move directly towards one another under the influence of their mutual gravitational attraction. What is the ratio of the distance traveled by m1 to the distance traveled by m2? Okay, so what we'll do, let's take the axis like this. So this is x-axis and this is the origin, and let us say that m1 was initially at origin and m2 is somewhere here, which is at a distance of r apart. Got it? So this is initial thing. Now after some time, I mean when they are released, these two are released and they move towards each other. So let us say at some instance t, m1 is at this position. This is m1, new position of m1, and it has covered a distance of x1, and m2 is here, m2. Because of their mutual attraction, they move towards each other, and m2 has covered a distance of x2 from its initial position. Now they're basically asking what is the distance of, I mean, what is the ratio of x1 by x2? What is x1 by x2? That is what they're asking. Okay, so obviously x1 and x2 are magnitudes only. So do you remember this? Velocity of center of mass is, okay, we'll start with xCOM. Yeah. xCOM is m1 x1 plus m2 x2 divided by m1 plus m2. Got it? So you can assume these two masses m1 and m2 as point masses, and you can apply this formula. Now if you take m1 m2 as system, together as system, then center of mass of the system will not be disturbed, because the mutual attraction is internal force. Internal force cannot alter the center of mass of the total system. So if you differentiate this with respect to time on both sides, d by dt of x center of mass is equal to m1 dx1 by dt plus m2 dx2 by dt divided by m1 plus m2. Now this thing becomes zero. Reason? The center of mass of the system will not get affected because there is no external force. So from here you can get this m1 into dx1 plus m2 into dx2 is equal to 0. So basically you are multiplying m1 and m2 with 0, and also you are multiplying this dt with 0. This can further be written as, if I integrate on both sides, you can write m1 delta x1 plus m2 delta x2 is equal to 0. So the small change is 0, then delta x1 is also 0. Now let us understand. We have almost reached the conclusion. m1 into delta x1. What is the change in position of mass 1? This is mass 1. This is the initial position. This is the final position. So final position is x1 comma 0. Initial position is 0 comma 0. So change in x is x1 minus 0. So I can write that here. That is x1 minus 0 plus m2 into delta x2. Change in position of mass 2. So initial position is r comma 0 and final position is r minus x2 comma 0. So final position minus initial position. So you will get r minus x2 minus r. Correct? So this is the final position and this is the initial position. So change in position. This will give what? m1 x1, r gets cancelled, minus m2 x2 is equal to 0. So x1 by x2 will be equal to m2 by m1. This is what they were asking, right? So what is the ratio of distance traveled by m1 to the distance traveled by m2? x1 by x2, that is m2 by m1. So the correct answer is option B. I hope this is clear. Let us move on to the next question. Look at this. A planet is revolving around sun. Which of the following is correct options? The time taken in traveling DAB, from here to here to here. So time taken in traveling DAB is less than that for BCD. Okay. If you remember Kepler's laws, there is one law which says that aerial velocity of the planet with respect to the sun is same. In other words, when planet is here, you can join sun and the planet, and finally it travels through this path and again goes to B. Planet is here. So what is the total area covered by the planet? Total area covered by the planet is this much. Correct. Next, the planet is here and it moves to C and again to D. So what is the total area covered by the planet? Area covered by the radius vector, basically. So that area would be this. Now tell me which area is greater. The red area is greater. And you know that aerial velocity is same. Therefore, greater is the area, more is the time it takes to cover that area. Therefore, the planet takes more time to travel from B to C to D than it takes to travel from D to A to B. Therefore, the correct option is A. So this is based on the Kepler law that says aerial velocity is constant, not equal, is constant. Got it? Let us go to the next question. The space between two concentric conducting spheres of radius A and B, where B is greater than A, is filled with a medium of resistivity rho. The resistance between the two spheres is how much? First of all, forget about spheres. Let us talk about what we already know. This is a metal bar of length L, area of cross section A, and resistivity rho. Then what is the radius offered by this what is the resistance offered by this metallic piece if it is connected across like this? If it is connected across these 2 points, this point and this point, what is the resistance offered? So you know the formula, R is equal to rho L upon A. You can see that area of cross section is perpendicular to the length. So let us understand, let us apply this similar concept here. Let me draw 2 circles. This is one circle. This is one more circle. Yes. And radius of this is A. Radius of this is B. B is greater than A. And this inside part, so this inside part, sorry, this part, this part is filled with medium of resistivity rho. So what you do, you take a small shell like this. Let me draw properly. Take a small shell like this, whose thickness is very small. So you can say this distance is x and this thickness is dx. Now look at only this small part whose thickness is dx. Look at only that. So I want to find out the resistance of this shaded region of thickness dx. Then apply same kind of formula here. So resistance dr, why dr? Because thickness is very small, so resistance is also small, is equal to rho, because the resistivity is rho, into length. See, basically this is the length, dx is the length, dx divided by area of cross section. What is the area of cross section of this thin sphere? 4 pi x square, because its distance from the center is x. So this is 4 pi x square. Here also you can see that this length is perpendicular to this surface, obviously. Same here. This area is perpendicular to this length. Now this is the expression that we got, and all you need to do is integrate this. So r is equal to rho by 4 pi integration of dx upon x square, and x ranges from a to b, so that is rho by 4 pi. And what is integration of 1 by x square? It is minus 1 by x. And put the limits a and b, substitute the limits now. So this becomes rho by 4 pi minus 1 by b minus of minus 1 by a. So this is rho by 4 pi 1 by a minus 1 by b, which is option A, right? This is the correct option. Moving on to the next question. A capacitor of capacitance 2 microfarad is first charged and then discharged through a resistance of 5 into 10 to the power 4 ohms. The time in which the charge on the capacitor will fall to 36.8% of its initial value is. Okay. So discharging of a capacitor through a resistance. So if you remember, the equation is something like this. Q is equal to Q naught into e to the power minus t by tau. This is when a capacitance is getting discharged through a resistor, where this is C and this is R, where tau is RC. So what do you call time constant is RC. Yeah. Now he's saying that the charge on the capacitor will fall to 36.8% of the initial value. So you can say 0.368 Q naught is equal to Q naught into e to the power minus t by tau. Q naughts cancel, and you can apply natural log on both sides. Ln 0.368, that is equal to ln e to the power minus t by tau. So this is approximately minus 1, that is equal to minus t by tau. Minus cancel out, so t is equal to tau, which is RC. What is R here? 5 into 10 to the power 4 into C, which is 2 into 10 to the power minus 6. So this comes out to be 0.1 seconds. And okay, I have done this in a long procedure, but you can just remember that the time taken for the charge to drop to 36.8% of its initial value is basically tau, that is RC. Got it? And this is the proof for that. Next question, please. Drift velocity of free electrons in a conductor is V when current I is flowing through it. If both the radius and current are doubled, then drift velocity becomes what? What happened? Okay. Look here. First, remember the formula of drift velocity or drift speed. Current is equal to NEAVD. So I is the current passing through the conductor. I is the current passing through the conductor, N is number of free electrons per unit volume or free electron concentration. E is the charge of one electron, which is 1.6 into 10 to the power minus 19. And A is the area of cross section. Sorry, yes. A is the area of the cross section and Vd is the drift speed or drift velocity. So according to this question, V, because he has given V is the drift velocity, is equal to I by NEA. Now radius and current are doubled. Radius and current are doubled. So we are assuming that the electron concentration, the charge concentration is not being affected. N is not being affected. So we can say directly V is proportional to I by A, or in other words, V is proportional to I by radius square, because area of cross section is pi r square. So we can say V1 by V2 is equal to I1 by I2 into R2 by R1 whole squared. So this is 1 by 2 into 2 square. So answer 2. Therefore, the new drift speed would be V1 by 2 or V upon 2. Answer is B. So are you able to understand? Yes. Now you may be asking, why is N not changing, number of electrons per unit volume? Because volume also changes if the radius changes. Obviously, volume is pi r square h. So radius becomes doubled and the volume becomes 4 times. Then number of electrons, free electrons per unit volume, why is it not changing? And see, when volume becomes more, then number of free electrons also increase. Therefore, number of free electrons per unit volume will stay constant. Next question. Look at this. A battery of EMF 10 volt is connected to a resistance as shown. This is 3 ohm, 1 ohm, 3 ohm, 3 ohm, 1 ohm. Yes. The potential difference VA minus VB between the points A and B are VA minus VB. Okay. Now, first of all, let us quickly solve this. So 1 and 3 are in series. So total will be 4. 3 and 1 are in series. Again, total will be 4. 4 and 4 are in parallel. So 4 and 4 parallel is 2. 2 and 3 are in series. So total will be 5. Therefore, the current through the circuit is 10 by 5, which is 2 amperes. So current is 2 amperes. Now that current will split at this point. You can see that both the paths have same resistance. This is 1 plus 3, 4 ohms, and this is 3 plus 1, 4 ohms. Therefore, current will split equally. So here 1 ampere current will be going and here 1 ampere current will be going. Now, once we have all this information, put the polarities. See, this is negative, this is positive. Now you can see that through this 3 ohm, current is flowing like this. Therefore, current always flows from higher potential to lower potential, like this, higher potential to lower potential in a resistor. Here also, plus minus, plus minus, plus minus, plus minus. After allotting all these polarities, what you do, you take any random point in the circuit and give it potential 0. You can do that actually, but you can do it only for one point. So you are taking that point as reference. So let me take that this is grounded, or you can say here potential is 0. You can do that. So here potential is 0 volt. So can you tell me what is the potential here? From here to here, potential is increasing by 10 volt. You're traveling from negative to positive. That means potential is increasing by 10 volt. So this point has potential 10 volt. Correct? Now again, you're traveling from here to here. So what is the potential difference across this resistor? Resistance is 3 and current is 2. So Ohm's law says V is equal to IR. That is, I is 2 and R is 3. This is 6 volt. Therefore, potential difference across this is 6 volt. This is positive, this is negative. So you're going from positive to negative. That means the potential is decreasing from here to here by 6 volt. And you already know that potential here is 10 volt. So what would be the potential here? This would be, this would be 6 volt. Sorry, not 6 volt, 4 volt. Reason? Because here the potential is 10 volt. I want to find out the potential here, and I know that potential drop between these 2 points is 6 volt. So 10 minus 6 is 4. Is it clear? That means this point is having potential of 4 volt. That means this point is also having potential of 4 volt, and this point is also having potential of 4 volt. ఎందుకంటే ఈ మూడు సేమ్ పాయింట్సే కదా, దిస్ పాయింట్ అండ్ దిస్ పాయింట్ ఆర్ హ్యావింగ్ ది సేమ్ పొటెన్షియల్. Now look at this resistor. Current is flowing like this, and what is the potential drop across this resistor? Again, Ohm's law, I into R. Current is 1 ohm and resistance also 1 ohm. So 1 into 1 is 1. So potential drop from here to here is 1 volt. And you know that potential here is 4 volt and drop is 1 volt. So potential at A will be 4 minus 1, that is 3 volt. Is it clear? Next, find out the potential drop here. What is the current through this resistor? 1 ampere, and resistance is 3 ohm. Therefore, the potential drop is 3 volt. So what is the potential here? What is the potential here? It is 4 volt. So it is 4 minus potential drop across this resistance. That is 3 into 1. 3 volt. 3 volt. So that is 1 volt. Now you got potential of A and potential of B. So simply do VA minus VB. That is 3 minus 1, which is 2 volt. So answer is option B. Am I correct? Yes. Understood? So you may be thinking, I have randomly allotted this point to have 0 volt. Okay, that is why I got answer as 2 volt. What if I take this as 0 volt or this as 0 volt? You can take any point as 0 volt and answer will be same, because this answer is not absolute potential. It is the difference in potentials between 2 points. Therefore, it will always remain 2 volt. No reference ekkadana disko, entaina disko. Potential difference across 2 points in a circuit will remain same. Next. A voltmeter has a resistance of G ohms and range V volt. Range V volt and a maximum value of potential difference that this voltmeter can measure is V volt. Or you can say that maximum potential drop across this voltmeter is V volt. The value of resistance used in series to convert it into a voltmeter of range NV volt is how much? First of all, let me draw a simple picture of this voltmeter. This is the voltmeter. Got it? And let me name this voltmeter G. Now you need to add a resistance in series to this voltmeter. So I can say this is resistance that is added in series, RS. Shunt resistance RSH antam. And this is series resistance kabatti RS antunam. Okay. Now, what is the maximum value of current that can pass through this voltmeter? Let us say that maximum value of current that can pass through the voltmeter is IG. This is the maximum value of current. When maximum value of current passes through this voltmeter, then the potential drop that occurs across this voltmeter is V volt. That is the question basically. Range V volt and maximum potential drop across the voltmeter is V volt. That happens when maximum current passes. Now he is saying that this, you have to convert this into a bigger voltmeter of range NV volts. So this is already V volt ante. Now this can be replaced with one more bigger voltmeter G dash, whose range is NV volt. Now already V volt is given here. That means across this series resistance, N minus 1 into V volt potential difference should be created so that this plus n minus 1 into V, if you add V plus n minus 1 into V, you will get NV. Therefore, you can say that the maximum potential drop across the series resistance should be n minus 1 into V. So that the total potential drop across the system will be NV. Now, current passing through the new voltmeter also should be IG only. Obviously, the maximum current cannot change. Now, just use the formulas that we already know. Applying Ohm's law across the voltmeter across here. If I apply Ohm's law, V is equal to IR. So V is equal to IG into R. R is basically G ohm. Now apply the Ohm's law here. I can write n minus 1 into V is equal to I into R. I is again IG into R is RS. Now substitute this equation into this equation. So let us solve this. N minus 1 into V is equal to IG is equal to V by G into RS. V cancels and RS is equal to G into N minus 1, which is option B. 39th question, option B. Is it clear? Yes. Next question, please. 40th question. A current of 2 amperes flows in a system of conductors as shown. The potential difference VA minus VB. See, if you understood this question, then this is kind of similar question to that. So let me quickly solve. I'll not spend as much time as I've spent in the previous question. Now this branch, you see what is the total resistance? 2 plus 3. This branch 5 ohms. This branch also 3 plus 2, 5 ohms. Therefore, this current will split equally because the total resistance across two branches are same. So you can say that the current here is 1 ampere and current here is 1 ampere. Got it? Now what you do, you take a point and give it zero potential, or you basically ground a point. Now I'm selecting point D and giving it 0 volts. Or you can say this is grounded. This point is grounded. Now you can see that current is passing from here to here in this 2 ohm resistor. Therefore, this is positive polarity, this is negative polarity. Same way, this is positive polarity, this is negative polarity for other resistance, this resistance. Now tell me, what is the potential drop across this resistance? Again, Ohm's law, V is equal to I into R. What is the current flowing through this resistance? That is 1 ohm. 1 into resistance is 2. So therefore, the potential drop is 2 volt. Got it? So potential drop across this is 2 volt. So what is the potential at point A? Potential at point A is potential at point D minus 2 volt. Potential at point D is 0 volt that we have decided, and potential drop is 2 volt. So potential at point A is 0 minus 2. So that is minus 2 volt. This is potential at A. Now talk about the other branch here. The current passing is 1 ampere and resistance is 3 ohms. Therefore, the potential difference is V is equal to IR, 3 into 1, that is 3 volt. Therefore, there is a potential drop of 3 volt here. So can you tell me what is the potential here? Potential here, which is 0 minus 3 volt, because you are traveling from positive to negative. So this will become, potential of this point will become 0 minus 3 volt, that is minus 3 volt. Now, what is the potential difference? VA minus VB. So VA minus VB, which is minus 2 minus of minus 3, that is 1 volt. This is the answer. Option B. Question number 40, option B. Yes, correct. Let us go to the next question. An ammeter of 100 ohms resistance gives full deflection for a current of 10 to the power minus 5 amperes. Now the shunt resistance required to convert it into ammeter of 1 ampere range is how much? See, earlier you have seen series resistance here, a resistance connected in series. Now we are going to see shunt resistance, that is resistance connected in parallel. So chudandi, this is an ammeter. This is an ammeter. And the maximum current that can be accommodated through the ammeter is 10 to the power minus 5 ampere. Now you need to connect a shunt resistance in parallel. See, the meaning of shunt resistance is only that. So let us say this is shunt resistance S, and there is some internal resistance to the ammeter, which I can call it as G. Correct? And what is the maximum current that can pass through the ammeter, which I can call it IG. What is IG? See, this is the maximum current that can pass through the ammeter earlier. So which is equal to 10 to the power minus 5 amperes. Now, this is the new ammeter. This entire system is the new ammeter whose current range is 1 ampere. That means the maximum current that can pass through the new ammeter is 1 ampere, which is, this is 1 ampere. Got it? So this 1 ampere will again split into two parts. 10 to the power minus 5 ampere will go directly like this, and rest will go through the shunt. So how much will go through the shunt? Tell me. So that is 1 minus 10 to the power minus 5 ampere. This much will go to the shunt. Now apply Ohm's law. Basically voltage across these 2 points is same through this path or this path, because these 2 points are the same. I mean, these 2 points are fixed. So voltage across these 2 points, across this path or this path, would be same. So using KVL, Kirchhoff's voltage law, you can say that what is the potential difference across, what is potential difference across this path? IG into G. So I can write IG into G is equal to, what is the potential difference across this path? That is I minus IG into S. As simple as this. So just substitute all the values given here. IG is 10 to the power minus 5, and G, which is the ammeter resistance, 100, original ammeter resistance, that is equal to I minus IG, which is 1 minus 10 to the power minus 5 into shunt S. Correct? So shunt is 10 to the power minus 3 divided by 1 minus 10 to the power minus 5, which is close to 10 to the power minus 3 only, because in comparison to 1, 10 to the power minus 5 is very small. So this difference will be almost equal to 1. Therefore answer is 10 to the power minus 3. Option C. Moving on to the next question. The region between two concentric spheres of radii r at A and B respectively has volume charge density sigma that is equal to A by R, where A is a constant, R is the distance from the center. At the center of the sphere is a point charge Q, which is here. The value of A such that electric field in the region between the spheres will be constant. Okay, so let us quickly draw this diagram. So this is the inner sphere, this is the exterior sphere, and there is a point charge at the center, which is Q, right? And this region between the spheres is having a volume charge density equal to A by R. Now what you do, you take a Gaussian surface between this, like this. Take a Gaussian surface, which is at a distance of R from the center. Now try to apply the Gauss law for this Gaussian surface. So what is it? Closed integral of E dot ds is equal to Q enclosed by epsilon naught. Correct? Now it is clearly stating that the electric field in the region between the spheres, that is electric field on this Gaussian surface, because this Gaussian surface is between the spheres, is constant. So this integration will enter inside. E will come outside because it is a constant. So you can write E into ds. Integration of ds will be S, which is 4 pi r square, because that is the surface area of this Gaussian surface. Correct? Which is equal to 1 by epsilon naught Q enclosed. Q enclosed is this charge Q and whatever is the charge that is included in this shaded region between this inner shell and the Gaussian surface. So basically Q plus, I can write that as small q. Small q is the charge that is present in this region, Got it? Now let us find out the value of small q. For that, what I do, take a thin shell inside the Gaussian surface of thickness dx. So thin shell radius is x and this thickness is dx for the thin shell. So what is the charge in that thin shell? So dq is equal to volume charge density at that thin shell, which is A by X. Actually it is A by R, but R is equal to X for that thin shell into volume of that thin shell. Volume of that thin shell is surface area into thickness. Surface area is 4 pi x square into thickness dx. So x and x cancels out. So this is 4 pi A x dx. This is dq. Now integrate on both sides and try to get the charge that is enclosed in the Gaussian surface. Not in the Gaussian surface, in this region between Gaussian surface and inner shell. So what are the limits that you need to put? Inner radius, that is A, and radius of the Gaussian surface, which is R. So this will become Q is equal to 4 pi A R square minus A square. Putting this value into this equation, you will get E is equal to 1 by 4 pi epsilon naught R square into Q plus 4 pi A R square minus A square. Got it? Now multiply this inside, you will get Q by 4 pi epsilon naught R square plus 4 pi cancel, R square also cancel. So you will get A divided by epsilon naught, if I am not wrong. Correct, na? 4 pi cancel, yes. Minus again 4 pi cancel, you will get A into A square divided by epsilon naught R square. Now group these terms. So you can write A by epsilon naught, and you can take 1 by R square common. or 1 by epsilon naught r square common, then you can write 4 by q by 4 pi minus a square. Now look at the question. The question says electric field in the region between the spheres is constant. So this electric field should be constant. If you look at this first term, a by epsilon naught, that is constant. But look at this second term, it is depending on r square. Correct or not? So that means the second term should be 0. That means this value should be 0. So if that value should be 0, this implies q by 4 pi is equal to a into a square. This implies a is equal to q by 4 pi a square. This is the answer. So no option is showing this. Just a minute. Okay, that's because we made a mistake here. So integration of x ds is x square by 2. That by 2 component we have not taken. That means this should be 2. That means this should be 2. So that is 2, 2, and this will be 2, and there should be a 2 here. Yes, if there is a 2 there, then this will I'll better solve this again. Here. So quickly doing this will be q by 4 pi epsilon naught r square, and 2 pi 4 pi cancel, so this will be a by 2 epsilon naught, and here also you will get minus of pi cancels out, and you will get a square divided by 2 epsilon naught r square. Yes. So grouping these terms together, you will get a by 2 epsilon naught, and taking 2r square common, or just take r square common, plus 1 by r square into q by 4 pi epsilon naught minus a square by 2 epsilon naught. So same argument, this electric field should be independent of r. That means this term should be equal to 0. If that term is equal to 0, then you will be getting q by 4 pi epsilon naught is equal to a square by 2 epsilon naught. Epsilon naught cancel. So you will get a is equal to, and 2, this 2 times, and q by 2 pi a square. So this is the answer, q by 2 pi a square, which is option B. Yeah. So the answer is option B. I mean, we have done a calculation mistake here, but the method is pretty much same. I hope it's clear. Let's move on to the next question. The force of attraction between plates of air-filled parallel plate capacitor having charge Q and area of each plate is A is given by how much? Okay. So this is the capacitor, and on each plate plus Q minus Q charge is there, and area of each plate is A. So can you tell me what is the electric field between the plates? So electric field between the plates, for example, if I talk about point A, at point A, there will be electric field due to the left plate, due to this plate. That electric field will be sigma by 2 epsilon naught. And there will be electric field at point A due to the right plate. That will also be sigma by 2 epsilon naught in the same direction. So total electric field will be sigma by epsilon naught. Now let us take force on each plate. So if I take this plate, charge of this plate is Q, and electric field that is between the plates is this much. Therefore, force is charge into electric field. So charge is equal to Q into electric field, that is sigma by epsilon naught, which is Q by A epsilon naught. So that is Q square by A epsilon naught. This is the force between the plates, option B. Now I have made a mistake intentionally here because there is a very, very important concept hidden. So we got answer as B, but answer is definitely not B. The correct answer is C, I suppose. Yeah, correct answer is C. So I just want all of you to pause the video for a while and figure out where we have done the mistake. Obviously, we have not done mistake like in the previous question. It's not calculation mistake. It's a conceptual mistake. So pause the video, figure out the mistake. Okay, coming back to the question. So what we have done here, the force acting on this plate, is electric field acting on this plate into charge on this plate. So electric field is this much and charge on the plate is capital Q, which is the force. The mistake here is that when you're writing the electric field acting on this plate, that electric field should only be due to this plate. But whereas sigma by epsilon naught is the total electric field at point A due to this and this. I want electric field at point A only due to right plate, not due to this. Because this will produce electric field here and that will in turn cause force on this plate. That is making no sense, na? Because at this point, find out the electric field due to everything else other than this plate. Everything else ante idokkate undi. So what is electric field at this point due to only this plate? It is sigma by 2 epsilon naught. That you need to multiply with this charge to get the force on this plate. You cannot take sigma by epsilon naught as electric field here. Yes, it is true that electric field at point A is sigma by epsilon naught. But the force on this plate is electric field at this point A due to everything other than this plate. అర్థమైందా? ఈ ప్లేట్ వల్లే ఇక్కడ ఎలక్ట్రిక్ ఫీల్డ్ కాజ్ అయ్యి మళ్ళీ అదే ఎలక్ట్రిక్ ఫీల్డ్ వల్ల ఈ ప్లేట్ మీద ఫోర్స్ ఉండదు కదా ఆబ్వియస్లీ. అందుకనే ఇక్కడ మనం చేసిన మిస్టేక్ ఏంటంటే ఈ ఎలక్ట్రిక్ ఫీల్డ్ ఇక్కడ మనం తీసుకోవాల్సింది సిగ్మా బై 2 epsilon naught. So this will be Q into Q by 2A epsilon naught, which is Q square by 2A epsilon naught. This is the correct answer. So B is not correct, C is correct. I hope this concept is clear to you. Once again, just I'm telling you in brief, the electric field at point A is sigma by epsilon naught only. There is no doubt in that. But when you want to find out the force on this plate, then you need to find out the electric field acting on this plate due to every other source. In that every other source, this source should not be included. So other source is only this. So what is the electric field acting on this plate due to this plate? That is sigma by 2 epsilon naught into charge on this plate. So sigma by 2 epsilon naught into charge on this plate. This is the answer. Next question, please. Yes. For the situation shown in the figure below, find the force experienced by the dipole. You see the question, it has given small dipole. First of all, dipole and enti, there are two charges. So this is minus q and this is plus q. And direction of dipole is this. And this distance is dx anukundam. Dx, because it is a small dipole, correct? And just a minute, let me shift this. Yeah, instead of dx, we'll better take dr. I'll tell you the reason. Let this be dr, and this is the main charge q, which is at a distance of r from this dipole. Now can you tell me what is this dipole moment formula? Dipole moment formula is charge into distance between the charges. Yeah, charge into distance between the charges, which is q into dr. That is the dipole, or you can call it as dp, because it is a small dipole. కానీ క్వశ్చన్లో p అనే ఇచ్చారు కాబట్టి pనే ఉంచుదాము. Yes. Now tell me what is the force acting on this dipole due to this. Now can you tell me what is the electric field on this dipole due to this charge? Electric field is very simple, which is electric field due to this charge in this region is what? Electric field is equal to q by 4 pi r square. This is the electric field. So I can say electric field at this point is E. Electric field here is E. Then what is electric field at this point? This point. Electric field will be slightly less because you are moving forward by a distance of dr. Therefore, you can call electric field here to be E minus dE. dE is decrease in electric field as you move from this location to this location. So now can you tell me what is the net force on the dipole? F net. F net on the dipole is basically E into minus Q plus Q into E minus D. Correct? So EQ and EQ cancel. So you will get net force is equal to minus Q into DE. Of course, let us ignore the minus because we want only magnitude of the net force. Now what I'll do, I'll do a mathematical manipulation of into dr by dr. So you can just group q into dr into dE by dr. Now what is this q into dr? Q into dr is dipole moment itself. Correct. Now, so that is equal to P into dE by dr. What is dE by dr? E is this. E is this. So differentiate it. You'll get how much dE by dr is equal to q by 4 pi 1 by r square differentiation. That is minus 2 by r cube. So if you substitute that here, okay, let us retain the minus also. Substitute that here, you will get F net is equal to minus P into Q by 2 pi r cube with a negative sign. So minus minus cancels out. So P into Q okay. Yeah, just a minute. I forgot to add epsilon naught here. This is 4 pi epsilon naught. Sorry. 4 pi epsilon naught. Yeah, here also 4 pi epsilon naught. Here also 2 pi epsilon naught r cube. Therefore, the answer is P into Q by 2 pi epsilon naught r cube. So which option is this? It is option A. You can see that. And P is basically has taken mod of P bar, which is magnitude of the dipole moment. That is what I have written here. I hope this question is clear. Move on to the next question. A charged particle Q is shot towards another charged particle capital Q, which is fixed, with a speed of v. It approaches capital Q up to a closest distance r and then it returns. If Q were given a speed of 2v, the distance of closest approach would be what? Try to understand this question. There is a capital Q that is fixed. There is a small q which is given an initial speed of v. And this distance is not specified. What is the initial distance between small q and capital Q? Therefore, what we can assume, we can take the distance to be very large, very big. Okay, so you can have an assumption here. Take initial distance to be very large. By doing this, by taking this assumption into consideration, we can ignore the initial electrostatic potential energy. That's the advantage we have. Now what happens when this charge is projected? It will keep moving towards capital Q, but as it keeps moving, due to repulsive force, it becomes slow. So at some point it will stop. Stop in the sense not permanently stop. It will momentarily come to rest and again retrace the position back. So this is called distance of closest approach. So let me say that this is the point where it has come to the closest approach. So momentary rest. And distance of closest approach is r according to the question. Now assume that this is position 1 and this is position 2. You know what to do. Total energy at position 1 is equal to total energy at position 2. At position 1, energy is half mv square. There is no electrostatic potential energy because we are taking initial distance to be very large. That is equal to energy at position 2. At position 2, kinetic energy is 0 and electrostatic potential energy is K capital Q small q divided by R. Perfect. Now, instead of V, you're projecting it with a higher speed to V. That time this R becomes R dash. Again, rewrite this same equation, energy conservation equation. You will get half m 2v square is equal to 0 plus K capital Q small q by R dash. Now this is equation 1, this is equation 2. Just divide those two equations, 1 by 2. You will get half m cancel. So 1 by 4 is equal to R dash by R. So this implies R dash is equal to R by 4. So distance of closest approach is R by 4. This. Moving on to the next question. What is the effective capacitance in microfarad between points X and Y maybe? Yeah. So you need to find out the effective capacitance between these 2 points. So how do you deal with these kind of questions? Just label them. It will be easy. So they're already labeled. This point is A, this point is C, this point is B, and this point is D. They're already labeled, right? Now just rearrange this figure. Now you want effective capacitance between X and Y. See, basically X and A are same points, Y and D are same points. So in other words, you need to find out the effective capacitance between A and D. So I can name this as point A and this is point D. Now look at this capacitor, 6 microfarad. This capacitor is between A and C, correct? So connect between A and C. Let us say this is point C, this is point B. Yeah. So I have labeled all the 4 points. I have rearranged all the 4 points. Now look at this capacitance, 6 microfarad. This is between point A and point C. So connect between point A and point C. This is 6, correct. Next, look at one more 6. This 6 is between point A and point B. So connect between point A and point B like this, 6. Now look at this 20. This is between point C and point B. So connect 20 between point C and point B. 20. Next, look at this 6. This is between point B and D. So connect between point B and D, 6. And the last 6, which is between point C and D. So between point C and D, connect 6. This is 6. So this is the circuit. This circuit looks complicated. This circuit looks easy to solve, correct or not? You can easily see that this is a balanced Wheatstone bridge, just like in resistances, correct? Because of which you can just delete this resistor. Now it is very simple. 6 and 6 are in series, so net capacitance is 3. Again 6 and 6 are in the series, so net capacitance is 3. And 3 and 3 are in parallel, so net capacitance is 6. Therefore the capacitance between A and B is 6. 6 is the answer. Is it clear? Let us go to the next question. The equivalent resistance between points A and B of an infinite network is this, and each resistance is 1 ohm. Then find A plus BC. Now try to understand one thing. This is point A, this is point B. If you just delete this part, then again you can treat this as point A and point B, no? Because this is an infinite ladder. In that infinite ladder, if you just delete one unit, it will not make any difference. Therefore, you can say that this is also point A and this is also point B. And let equivalent resistance between point A and point B is X ankundama, X. So this you can redraw as, this is point A, this is point B, this is 1 ohm, this is again 1 ohm, and this is X. This is X because see here, this is point A and point B, so all this entire network can be replaced by X. That is what I have done. And you know that equivalent resistance between A and B is also X. So X is equal to parallel combination of 1 and X plus series combination of 1. I hope you understood. And 1 and X you take parallel and then you add it to 1, then you should get X. So if you solve this, X is equal to 1 into X by 1 plus X plus 1. So this will become 2X plus 1 divided by 1 plus X. Multiply 1 plus X into X. So this will be X plus X squared, that is equal to 2X plus 1. So you will be getting X square minus X minus 1 is equal to 0. Now this is a quadratic equation and you know how to solve quadratic equation. So roots of a quadratic equation is minus b plus minus under root b square minus 4ac by 2a. I don't have to tell this. So minus b is minus of minus 1, that is 1, plus minus under root b square, which is 1, minus 4ac, which is 4, divided by 2a, which is 2. So place ledu ikkada. So you'll get x is equal to, you ignore the negative root because answer can't be negative. So you take only positive root, it is 1 plus root 5 by 2. So comparing A, B and C with 1, 5 and 2, you get A plus BC. Okay, here A plus BC, that is 1 plus 5 into 2, that is 11. So you'll get answer as 11. Is it clear? So answer is 11. Next question. An artificial satellite is moving in a circular orbit around the sun. Artificial satellite is moving in a circular orbit around the earth with a speed equal to half the magnitude of the escape velocity on the earth. Okay. The height of the satellite above the surface of the earth is xr, then the value of x is how much, right? So just write the condition that he has given. What is the condition? Escape orbital velocity of satellite is equal to half the magnitude of escape velocity. Just substitute. What is the orbital velocity? It's very clear. It's very easy. It is root gr. I'm sorry, it's not. Orbital velocity of the satellite is basically under root capital G, capital M by R. See, root gr is orbital velocity very close to the surface of the earth. But it's not given that the artificial satellite is very close to the surface of the earth. That is equal to half into escape velocity on the surface of the earth. What is escape velocity on the surface of the earth? That is basically 2 capital G capital M by capital R. Yes, is this correct? Now square on both sides. G capital M by R is equal to 1 by 4 into 2 capital G capital M by capital R. GM cancel. And this also 2 to cancel. So you'll get small r is equal to 2r. That means what? The orbital radius is 2r, or height of the planet. So basically, if this is the planet, this is the satellite, this distance is 2r. So what is the height of the planet from the surface of the earth? So height is equal to 2r minus r, which is r. That is equal to xr given. This implies x is equal to 1. So answer is 1. Moving on to the next question. Look here. The charge on the capacitor in a steady state is x microampere. You can see that there is only one capacitor in this diagram. So charge on this capacitor at steady state. See, forget about everything. This capacitor is directly connected to this battery. Therefore, the potential difference across this capacitor is 1 volt only. Correct. So what is charge on the capacitor? Charge on the capacitor is C into V. Capacitance is 1 microfarad into potential difference across the capacitor is 1 volt. So that is 1 microcoulomb. Therefore, X is equal to 1 again. This is the most simplest question. Moving on to the next. Listen. The minimum energy required to launch a satellite of mass m from the surface of the earth of radius r into a circular orbit of altitude 2r is this much. Then what is the value of x and y? Okay. Try to draw the figure. It will be clear. This is the earth. And this is the satellite. Correct? And distance between the earth and the satellite, this distance is how much? You tell me. Altitude is 2r and distance will be 3r, right? Because it is already given that this altitude is 2r. Look here. Then question is, what is the energy required to launch the satellite on the surface of the earth so that it will keep moving in this orbit? That is the question. Again, same thing. Consider this as 0.1, consider this as 0.2. Then energy conservation, that's all. Total energy at 0.1 is equal to total energy at 0.2. So what is the total energy at 0.1? At 0.1, there will be some gravitational potential energy, which is minus G capital M small m divided by R, plus the kinetic energy that is required. Basically, that kinetic energy is the minimum energy required to launch the satellite. So this K is what we are looking for. That is equal to total energy at 2. Total energy at 2 is potential energy plus kinetic energy. And this, I don't have to write potential energy and kinetic energy separately. You already know what is the total energy of a satellite orbiting. It's directly equal to minus G capital M small m by 2 into radius of the orbit. Radius of the orbit is 3r. Correct? You know, no, for an orbiting satellite, total energy is minus G capital M small m by 2r. Potential energy is minus G capital M small m by r. Kinetic energy is capital G small m capital M small m by 2r. This is something you need to remember. And on this, we got a question also earlier, that graph question, something like this. Remember? So I'm writing total energy formula directly here. So solving this, you will get K is equal to minus G capital M small m by 6r plus G capital M small m by r. So take G capital M small m by r common, 1 minus 1 by 6. So this is 5 by 6. 5G capital M small m by 6r. This is kinetic energy, or this is the minimum energy required. Compare this with whatever is given in the question. What is given in the question? Xg capital M small m by yr. So x is 5, y is 6. So x plus 5 is 5 plus 6, which is 11. 11 is the answer. So did you all understand this question? 11 is the answer. Thank you for giving your time. I hope you have understood this analysis. All the best for your further part tests and grand test, and most importantly, JEE Main first attempt. See you again. Bye bye.